Okay, here we go with this today. We're still working on reviewing a little bit here. So going through this one, when I see a problem like this, first of all, my eyes are attracted to the numbers, so I'm going to divide those. 4 will go into 6 one time with 2 left over, and 4 will go into 28 7 times. All right, now I'm done with that. So the f to the fifth, that stays right there in the top. G to the negative third goes down to the bottom. G to the sixth stays in the bottom. F to negative third goes in the top. So I'm going to put 17, add the exponents, F to the eighth over G to the ninth. So that's what I would get with that one. Now for this one, as I see this, well, nothing's going on with this first part, but the parentheses and the negative 2 there is. So let's just go through this a little bit at a time. I'm going to leave that first part exactly as it is. But the back part, that negative 2, makes that whole thing move down to the bottom. All right. So now, again, the first part stays exactly the same. And now let's get rid of those parentheses. So I want to square everything. Negative 3 squared is 9. N to the second power is m to the fourth. And n to the third to the second power is m n to the sixth. Reduce the numbers just like before. That's 2/3. M to the fourth divided by m to the fourth, that's 1. So I'm going to just mark those off. And where are there more n's? In the top or the bottom? Well, in the top, there are 3 more. So n to the third. Now moving into what we're working on today. Today we're working on simplifying radical expressions. Okay, radical expression is something with the square root or something with that type of symbol going on. So we can't have any perfect square, so we got to make sure we get rid of that perfect underneath there. And we can't have any radicals in the bottom of the fraction. In the bottom of the fraction must be a whole positive whole number, so we got to get rid of those. So here we go with this. My suggestion with these is anytime I see a problem like this, the first thing I'm going to do is I'm going to divide it by 2. So if I divide that by 2, I get 10. And then I go to the next perfect square, which is 9. And I try to divide, will 9 fit evenly into 20? Well, it won't. So that one didn't work. So then I go to 4. Will 4 go in there? Well, it will. 4 times 5. I always put the perfect square there because that's going to be the number that I simplify first. So the square root of 4 is 2. The square root of 5, I have no idea. So I'm going to leave that alone. So there's my final answer for this one. Now, this next problem is one that you'll see frequently, and there's a couple different ways. When a lot of people see this, they think of 4 times 8. Well, the good news is 4 is a perfect square, so that's a good choice. So that's 2 times root 8. Now, I'd love to be done here, but I'm not. So the square root of 8 is 4 times 2. So this is 2 times the square root of 4 times the square root of 2. Well, the square root of 4 is really 2. So this is 2 times root 2, 4 root 2. All right, that seems like a long, hard way around this particular problem. Well, let's say if we take into my account the way that I was suggesting. If I take 32 and divide it by 2, that is 16. 16 is a perfect square, so it would be 16 times 2. Well, the square root of 16 is 4 root 2. A lot faster, probably much more likely to get this correct. I would suggest that's why I want you to divide it by 2 and then go from there. I just think it makes it easier. It makes it more likely that you'll get it correct. All right, now let's introduce some variables with this. Okay, anytime I see this is regular square root, so anytime I see something here, I want to take the biggest even number out. So start with the numbers. 36 is a perfect square, so that's good. This is an odd exponent, so I need to take as many out as I can, but unfortunately I'm going to leave 1. So if I take x squared and I leave x to the first, notice that these two exponents add up to make this one. All right, now the square root of 36 is 6. The square root of x squared. Well, what times itself is x squared? Well, that's just x. What you end up doing is you just divide this exponent by 2, and that's whatever the exponent is here. Now, x to the first, hey, I don't know what that is. That's going to come along for the ride. All right, 18. Well, that's 9 times 2. X to the third. Let's take out x squared, and let's leave an x to the first there. Y to the second, that's even. Let's take that out, and I don't have to do anything there. So now, the square root of 9 is 3. Square root of x squared is x. Square root of y squared is y. And then the square root of 2x. All right. 2, this 2 out front, that just comes along for the ride. It's 2 times whatever I get. Now, 48, that's a tough one. A lot of people think 8 and 6, but neither 8 nor 6 is a perfect square, so that's a bad choice. 24 and 2, bad choice. But let's decide. Let's divide this by 2. That's 24. The next perfect square down is 16. Well, that's the winner. It's 16 times 3. X to the fourth, that's even. Let's take them all over here. All right, so this is 2. The square root of 16 is 4. Square root of x to the fourth is x squared. And now 4 times 2 is 8. X squared, the square root of 3. All righty. Now, what happens if I have a square root in the bottom? That's called rationalizing the denominator. Now, the goal for this is to get to the next perfect square. That's the easiest way to do this. So like when I see 2, I can multiply this by 8. And when I do this, I really can't change the value. So I'm just, the square root of 8 divided by square root of 8 is 1. So I'm not changing the value any, but I do change the number some. Now, the problem with this is I can break down the square root of 8. And this is the square root of 16. So this is the square root of 8 over 4, but I can break 8 down further, and then it just ends up to be messy. And so the easier way to do this is just to multiply it by itself. If I multiply the top and bottom by the square root of 2, this is the square root of 4. Square root of 4 is 2. And now I'm done. That is the easiest way to do this. But really what we're doing is we're trying to take it up to the next perfect. So like this one, I would take it up to 25. So this is 2 root 5. This is the square root of 25, which is just 5. So like this one, I multiply the top and bottom by the root 10. So I get root 10 over 3 times root 100. Well, that's root 10 over, this is really 10, so over 30. That's my answer. That's all I got to do for these. Okay, so that's what you have for today. I'm sorry this doesn't, I don't know why I have that on there. This is what you guys have to do for today. It's a nice little review. Tomorrow we'll start into doing a little bit more from 6-1. That's about it. Have yourselves a good day.